Yo, code pilots. Welcome to part 4 of the Python Masterclass, Data Structures. We've mastered arrays and stacks, and now we're moving to queues. If you're new, check the playlist, link for Python Basics and OOP. Let's dive into this queue of knowledge with full energy. Let's explore what a queue is. A queue is a linear data structure that follows the FIFO principle, first in, first out. Imagine standing in line at a store. The first person who joins is the first to be served. In a queue, we add elements to the rear with enqueue and remove them from the front with dequeue. This orderly flow is perfect for scenarios where tasks must be handled in the order they arrive, like processing customer requests or managing print jobs. Unlike stacks, which use LIFO, queues ensure fairness by prioritizing the earliest entry. We'll implement this in Python using Jupyter Notebook, breaking down each step to see how this structure organizes data effectively. Let's get started. Why are queues so essential in programming? They're everywhere. In operating systems, queues manage processes waiting for CPU time, ensuring each gets a turn. In web development, they handle incoming requests to prevent server overload, processing them in order, which is crucial for systems where timing matters. We'll use Jupyter's interactive environment to code this up, making it easy to see how queues handle data flow. Let's move to the practical side and build one. Let's create a basic queue using a Python list in a new Jupyter cell. Type queue equals empty brackets and run it to start with an empty queue. Now use queue.append 1 to enqueue 1. This adds it to the rear, making it the first in our FIFO sequence. Run print, open quotes, after enqueuing 1, close quotes, comma, space, queue, close parenthesis, and you'll see open square bracket 1, close square bracket. Let's add more, queue.append 2 and queue.append 3. Then print again. Output is open square bracket 1, 2, 3, close square bracket with 1 at the front and 3 at the rear. To dequeue, use queue.pop 0 to remove the front element 1 and print queue. Now it's open 2, 3. The append method adds to the rear, and pop 0 removes from the front. But note that pop 0 shifts all elements, which can be slow for large queues. Let's dive deeper into this and improve it. Let's build a custom queue class to give us more control. In a new cell, type class queue, define init self. Remember, self items is an empty list for queue items. Define enqueue self item. Self items append into the rear. Print enqueued item current queue. Print dequeue if not empty isn't empty. Return self items pop 0. Removes and returns the front item. Else left not experience. Print error. Queue is empty, cannot dequeue. Return none. Def is empty self. Return len self items equals 0. Returns true if no items. Return len self items. Returns the number of items. Create it with my queue equals queue and test. My queue enqueue 10. My queue enqueue 20. Print f dequeued my queue dequeue dequeue. Output shows enqueued 10, enqueued 20, and dequeued 10. Here enqueue uses append to add to the rear, and dequeue uses pop 0 for the front. However, pop 0 has O(n) complexity because it shifts elements, which can be inefficient for big queues. For better performance, we could use collections.deque later, but this gives us a solid base. Let's test it with a real example. Let's simulate a print job queue as a practical use case. In a new cell, add def print jobs jobs. Print queue equals queue. Print queue and quote enqueue, while not print queue is empty. Current job is dequeue. Print processing job. Doc1, Doc2, Doc3 PF. Print jobs jobs list. Run it. Output shows each job enqueued and dequeued in order, like a printer handling files. Added job Doc1 PDF, added job Doc2 PDF, added job Doc3 PDF, then processing job Doc1 PDF, and so on. This FIFO flow ensures jobs are processed fairly, mimicking a real printer queue. The while loop keeps dequeuing until the queue is empty, a common pattern in task management. This example shows how queues maintain order, which is vital in systems like print servers or task schedulers. Let's reflect on its significance. To wrap up, we've deeply explored what a queue is with its FIFO principle, implemented it using a list and a custom class with enqueue, dequeue, isEmpty, and size, and applied it to a print job simulation. We learned how append adds to the rear and pop0 removes from the front, noting the efficiency trade-off with large data. Queues are key for managing tasks sequentially, from operating systems to everyday apps. And this hands-on approach in Jupyter helped us see every step. This prepares us for linked lists next, where we'll see a different way to handle data. Let's get excited for that. That's it for Part 4 Code Pilots. You've conquered queues and their applications. Like this video, subscribe for more, and practice with the queue class and print job code. Try it with your own job list. Next time, we'll dive into linked lists, so stay tuned, keep coding, and see you in the next one.